During our last class, we talked about degree of reaction and utilization factor. So degree of reaction R is equal to H1 minus H2 divided by H01 minus H02. Now the subscript 1 and 2 correspond to inlet and outlet, and H1 and H2 are static enthalpies and H01 and H02 are stagnation enthalpies. For energy utilization, E is energy produced divided by E plus B square by 2, and that afterwards we found out that there is a relation between degree of reaction and utilization factor, and that was epsilon equal to V1 square minus V2 square divided by V1 square minus R V2 square. यहाँ तक हमने लास्ट क्लास में कर लिया था. अब हम एक्सियल फ्लो मशीन्स के लिए ये पूरा एक एनालिसिस डिग्री ऑफ रिएक्शन को लेके करते हुए चलेंगे. यहाँ पे हम इंटरेस्टेड हैं what happens in those machines where R is equal to 0, 0.5 and R equal to 1. R equal to 0 or 0.5, these are of practical relevance, and R equal to 1 is something which is not much of practical relevance, but it's something which would give us insights into what happens when degree of reaction is equal to 1. हम एक्सियल फ्लो मशीन लेके चलेंगे जिसमें कि हम ये कहेंगे कि ब्लेड वेलोसिटीज इनलेट और आउटलेट पे सेम होती हैं, यानी कि U1 बराबर U2 बराबर U के. Now typical velocity triangle for an axial flow impulse machine is shown in figure 5a. Here you can see the velocity triangle. When we are using subscript 1, then it means that the velocity triangle is at the inlet. For subscript 2, the velocity triangle is at the outlet. Maximum utilization अगर हमको चाहिए, maximum utilization, then you can see from the equation that V2 should be minimum. Minimum V2 0 हो, but this is not possible. We can't have V2 to be 0, और ये last class में हम discuss भी कर चुके हैं कि एग्जिट पे कुछ तो हमको काइनेटिक एनर्जी की ज़रूरत होगी. अगर फिगर 5a को देखेंगे और फिगर उसके बाद में फिगर 5b को देखेंगे तो समझ में आएगा कि मिनिमम V2 हमको मिल सकता है जबकि V2 एक्सियल हो, यानी कि V2 और U के बीच का एंगल 90 डिग्री हो. So for maximum utilization, V2 should be minimum. From figure 5b, V2 is minimum when it is purely axial. Then, looking at this triangle, we can say that V2 is equal to V1 sine alpha 1. So maximum utilization epsilon m. Instead of V2, we need to write V1 sine alpha 1, and we would get the relation that this is equal to cos square alpha 1 divided by 1 minus r sine square alpha 1, and this is our equation 23. Maximum utilization is very high for low values of alpha 1. यानी कि जब alpha 1 nozzle angle की बात कर रहे हैं, ये less than 20 degree है, तो utilization is very high, value for maximum utilization, and then it falls quite rapidly afterwards. And this factor is important in deciding inlet nozzle angle for impulse turbines. One of the impulse turbine for which you would do experiment, or you might have already done the experiment in the lab, is Pelton wheel. अगर इक्वेशन 23 को हम ड्रॉ करते हैं, ग्राफिकली उसको देखते हैं, then this would be something like this. यहाँ पे ये तीन कर्व दिए गए हैं for r equal to 0, r equal to 0.66, r equal to 1. So this is maximum utilization factor with respect to alpha 1, nozzle angle alpha 1. Now let us see what happens when we have different values of r. ठीक है? For many axial flow turbine stages, r would be equal to 0 or 0.5, यानी r 0 होगा या r half होगा. एक्सियल फ्लो टरबाइन स्टेजेस में। हमें मालूम है कि एक्सियल फ्लो मशीन में U1 बराबर U2 बराबर U होता है, and this is something which you can see. Let's say if I have a runner and a blade on it, तो फ्लो इनलेट से आया, आउटलेट पे चला गया, इन दोनों पॉइंट्स पे R यानी कि सेंटर से इनका डिस्टेंस R इज सेम, सो R1 इज इक्वल टू R2। इसी वजह से हमको मालूम है कि U बराबर है ओमेगा R, ओमेगा इज कांस्टेंट, so we can say that U1 is equal to U2 is equal to U। फर्स्ट केस को देखते हैं जहां पे के degree of reaction is 0, R equal to 0, and this corresponds to pure impulse turbine और stage। यहाँ पे हम टरबाइन और स्टेज की बात कर रहे हैं, वो इसलिए कि कुछ टरबाइन में मल्टीपल स्टेजेस भी हो सकती हैं, और एक ही टरबाइन के अंदर में एक ही शाफ्ट के ऊपर में मल्टीपल स्टेजेस इस तरीके से लगी भी हो सकती हैं कि स्टार्टिंग की स्टेज डिफरेंट हो विद डिफरेंट आर, और बाद में स्टेजेस में आर की वैल्यू डिफरेंट हो। फॉर आर इक्वल टू 0 the corresponding diagrams are shown in figure 6a and 6b। ठीक है, अगर हम इक्वेशन 20 को देखते हैं जो लास्ट क्लास में थी, फॉर r इक्वल टू 0 वी वुड गेट w1 इक्वल्स टू w2। ओके, अगेन फॉर मैक्सिमम यूटिलाइजेशन v2 नीड्स टू बी एक्सियल, v2 u से 90 डिग्री पे होना चाहिए। अगर ऐसा होता है, then if we would look at triangle ACE, since W1 is equal to W2, which means that triangle ACE is isosceles, and that proves that CD would be equal to DE, and this would be equal to BC, and all of them are equal to U, blade velocity. Also, V2, which is V axial, would be equal to V1 sin alpha 1, and Vu1 would be equal to 2U, and Vu2 is going to be 0। अगर ऐसा है तो एनर्जी हमारे पास में 2U स्क्वायर के बराबर आएगा, और मैक्सिमम यूटिलाइजेशन फैक्टर हमारे पास में cos स्क्वायर अल्फा 1 के बराबर आएगा। ऑल ऑफ दीज आर फॉर R equal to 0, degree of reaction 0, purely impulse stage, impulse turbine। अब हम नेक्स्ट डिस्कस करते हैं व्हाट हैपेंस व्हेन R equals to 0.5 or we are talking about 50% reaction turbines। Putting R equal to half in the expression for degree of reaction, we would get that V1 square minus V2 square would be equal to W2 square minus W1 square, and this is our equation 25। Now equation 25 is non-linear, and therefore there would be multiple solutions for it। Okay, now as a homework, I would like you, as a side homework in your notebooks, I would like you to solve equation 25 and get those solutions। Now one solution of equation 25 is V1 equal to W2 and V2 equals to W1। This is one of the solutions, and for this case the velocity triangle would be symmetric as shown in figure 7a। Now we know that for maximum utilization V2 must be axial as shown in figure 7b, and this gives that V2 equals to W1, which is equal to V axial, which is equal to V1 sin alpha 1। From this we would get that Vu1 is U and Vu2 is equal to 0, and from there we would get that energy would be equal to U square, and maximum utilization would be equal to cos square alpha 1 divided by 1 minus 0.5 cos square alpha 1। This is equation 26। Now equation 24 और 25 को अगर हम देखते हैं, then we find out that impulse turbine produces twice the amount of power as reaction turbine for same blade velocity and nozzle angle, but less efficiently since utilization factor is lower। Now this thing has implication in deciding the number and type of stages in a gas or steam turbine। यानी कि शुरुआत के अंदर में इनलेट पे हम कौन सी स्टेजेस यूज, कौन सी टाइप ऑफ स्टेज यूज करें, क्या इम्पल्स स्टेज यूज करें यानी R इक्वल टू 0 वाली स्टेज यूज करें या R इक्वल टू 0.5 50% रिएक्शन स्टेजेस यूज करें और कितनी यूज करें, and we would get the answer a bit when we move ahead. So a compromise between higher power production and higher utilization is to use impulse stages for higher pressure and temperature. And high pressure and temperature exist near entry to gas turbines. So near the entry to gas turbine, यानी जहाँ पे इनलेट है, इनलेट के ऊपर में हम इम्पल्स स्टेजेस यूज कर रहे हैं, यानी कि R इक्वल टू 0 वाली स्टेजेस यूज करेंगे, एंड देन वी यूज 50% reaction stages afterwards. Now let's look into another factor which is important in determining the shape of impulse blades, and this is known as the peripheral velocity factor phi, and this is equal to U divided by V1. Okay, so we get that phi equals to 0.5 cos alpha 1 when R is 0 and phi equals to cos alpha 1 when R is 0.5. So we have already talked about R equal to 0, R equal to 0.5. Now let's move on to R equals to 1. तो जब R को हम 1 के बराबर रखेंगे R के एक्सप्रेशन में, डिग्री ऑफ रिएक्शन के एक्सप्रेशन में, तो हमको मिलेगा V1 बराबर V2, और उसके लिए जो वेलोसिटी ट्रायंगल्स हैं वो फिगर 8 के अंदर में दिखा रखे हैं. ओके, you can even look into R greater than 1, but R greater than 1 is relevant for blowers and centrifugal fan. These are energy consuming machines, and we are since currently involved in those machines where which produce energy. So let's defer this discussion at a later stage, what happens to R greater than 1. Now for R equal to 1, axial velocities are equal at inlet and outlet, and in figure 8b we have used axial velocities as different. So the impulse stages handle higher pressure and correspondingly higher densities, and there is relatively less pressure drop. Therefore the blades are shorter with higher curvature. जो शुरुआत की स्टेजेस होती हैं, इम्पल्स स्टेजेस होती हैं, या अगर हम इम्पल्स टरबाइन की बात कर रहे हैं, सिंगल स्टेज भी है, तब भी इम्पल्स स्टेजेस जो होंगे उसके डिजाइन में ये दिखाई देगा कि ब्लेड शॉर्टर होंगे, हायर कर्वेचर होगा, एंड द रिएक्शन स्टेजेस टेंड टू बी लॉन्गर एंड ब्लेड कर्वेचर इज आल्सो मच लेस. In this picture you can see this is a picture of an actual turbine with different stages, multiple stages. इनलेट के ऊपर में आप देखेंगे इम्पल्स स्टेजेस हैं, और you would see that the length is short as compared to later stages which are near to the outlet, which are reaction stages. Okay, L is greater than smaller, and even the curvature, if you would look from these pictures, the curvature you would find out that it is more for impulse stage than in the reaction stage. And this finishes this lecture.